and I'm observing that the differences when I look at the histogram, it starts to move towards left. What is your interpretation?
Well, the average image is being shifted towards 128 bits.
No. What's your name? Woman. What do you think? What's your name?
Nathan,
Nathan, what do you think?
I think it's getting closer to 0.
Absolutely. Look, this is 0. So it says that the differences, first is big, as we are going, the differences start to become smaller, 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 and ideally, we have no difference, and it's only 0, right? So, no more differences. So this is a very, very important thing that we have to observe. So this is a type of question that might be asked in the exam. So your comment and your observation is something which is important for you. Now, what happens is that when we do the image processing per se, we said that we are doing lots of work on the whole image, like histogram localization. It was a pixel-wise operation. You pick up the pixel, its value was 120, and you calculate it and say that what is the new value. You don't care about what is happening around this pixel. But not all the time we do something like this. Sometimes we care about, before you change me, I care about what is happening around me, and accordingly I decide that what should be the value. So in order to do this, we have an operation which is called filtering, or masking, or kernel operation. So we have these words which are similar to each other in this course. So when I am talking, depends on my mood, I may use different words. Mostly I use the word filtering, or mask, or very rarely I refer to the word kernel. If you use different image processing book, you may see that sometimes they call these operations that we will talk about as a kernel operation. Sometimes they refer to it as a mask operation. In our book, mainly they refer to it as a filter operation, right? So what happens here, from now on, if you want to do a process, we don't look at one single pixel, we look at the pixel and its neighborhood. Oh, this is another word which is being used. It's called also a neighborhood. Neighborhood processing, neighborhood operation, right? So, and when we are doing this, filtering, you can do it either in a spatial domain or in frequency domain. What is a spatial domain? A spatial domain means this domain that we are living in, right? If it is in 1D, it's called time domain, right? If it is in 2D, it's called the location. It's what we are living. If you want to see something, it must be in a spatial domain. However, we can transfer the domains and we can go to something which is called frequency domain. We have a full chapter about it, a couple of weeks we will talk about it, so currently we don't talk about it. Now, and when we are talking about the filtering, we have two types of filtering. Linear filtering, or it's called convolutional or mask or kernel, or we have non-linear filtering, which in your project you might see, but in the course we don't talk about it, right? So I teach you easy things, I will ask difficult things later. So when we are talking about the neighborhood process, so the thing is that we have to define what is a neighborhood, right? What is a neighbor? Typically, when we are talking about a filter or a kernel, next to it we have to specify what is the size of the filter. Now, the size of the filter that we have, and you will face it in this course a lot, is either 3 by 3 or 5 by 5, right? As you may notice in lots of examples that you will do also in the practical, we are using odd numbers. In a few seconds you understand why we are using odd numbers. So, let's consider a 3 by 3 neighborhood. In order to define a neighborhood, you have to first define who is the center of interest, right? So in order to tell you about who is the neighbor, I have to say that I'm talking about my neighbor, so you can look at my house and define who's my neighbor, right? So always the center of the interest is the middle pixel. So in order to have a middle pixel, you understand that the size should be odd number. So the center is the place that you put on your main pixel that you want to calculate the new value. You give the index of 0, 0. And then I say 3 by 3, it means that 1 to the left, 1 to the right, 1 to the up, 1 to the bottom, and then you are making a 3 by 3. If it is 5 by 5, it means you are in the center, so 2 to the up, 2 to the bottom, 2 to the right, 2 to the left, and then you will make the S-curve. And then here is your position of your neighbors. Now, we have lots of different type of filters. We will maybe study 4 or 5 of them in this course. All of them, all 3 by 3 filters that you see have this form. What is the difference between them? The weights that you are assigning to each of this one. Now, what is a weight? It's like this. Let's say that you want to make a party in your neighborhood, right? In your neighborhood, you want to make a party, and you want to buy drinks, right? But because you're a good person, you ask all your neighbors what drink you have to buy. If you love beer, of course, you love yourself more, so you are very important, so it is dominating. And then let's say that your other neighbor is your best friend, so what your other neighbor says is also important, but that neighbor is not really very, very good to close friends, so if he says, I want this, you say, okay. Right? So this means that you put a very good weight on yourself, Martin. You give relatively higher weight on the other one. And this neighbor, you don't give a weight at all. You put 0 or you put a small value. In other words, you do not need to treat all your neighbors similarly. But what happens, you will look at all of them. So let's say that you have lots of huge neighborhood. You give yourself high value, you give your other neighbor, your best friend also high value, but there are 20 more neighbors that you are talking about, and all of them wants whiskey, let's say. So what happens, we may say that, okay, because the majority now wants this, although the high weight one wants something different, you are dominating on that one, right? So this is the whole story that goes on. So we will look at all the neighbors in order to decide what should happen instead of let's pick the new value for the pixel of interest. Now, how it works is pretty simple. You have the big image. This is the mask that you have. You take your 3 by 3 mask. You place it on the image. How do you place it? You want to calculate the new value for this pixel. You want to calculate the new value for this pixel. So you put your mask in a way that the center of the mask will sit on that pixel of interest. And then you do the arithmetic operations that you need to do. And all today, next week, we will talk about these arithmetic operations that we have to do. The first thing that we discuss is called convolution. Those of you who have taken DSPs or signal processing before, you know convolution. Some of you hate convolution. Some of you fail because of convolution. Some of you may like the convolution. So, who doesn't know what is a convolution? Okay, so the rest know what's convolution. So, Martin, what's convolution?
You mean the mathematic perspective or something?
I think Martin is this guy. Your name was Claude, right? Yeah.
Sorry.
That's it. What's convolution? What's the do you remember convolution from signal processing? Have you taken signal systems?
No.
No. Those has taken signal system? Yes, you have taken signal system.
I've taken.
Do you know what is a physical representation of convolution? Those of you who took DSP from me, you should know it. This I gave this example. Don't Wikipedia it. I already have done it. I have done
I
it.
used to have. I think I used to join the signal processing and.
Who knows? What's the physical? Yeah.
It's you have like these two signals and you take the part that isn't the same for two signals.
No, that's correlation. What is the physical representation of convolution? We have it a lot in our life. You have seen this zillion times, yes?
Maybe a pattern?
What pattern?
Was it shadow?
Shadow. Shadow is a convolution of the light and your body or an object, and you see the shadow. So convolution means that something, mathematically speaking, some linear response, some linear input comes to your linear system, and you know what is the impulse response of this system, and you try to guess what should be the output, right? So what is convolution in image processing? Do you know what is the physical meaning of convolution in image processing? Charlie, do you know what is the physical representation of convolution in image processing? It's nothing. It's nothing. Convolution in image processing does not have any representation. It's a tool which is being used to do some effect on an image, like sharpening, like blurring, like finding an edge. So it means that I will say something, but you are not responsible for that. Convolution is like the impulse response of your linear system, which when you are giving an image into it, it tells you what is the output. Right? Now, mathematically speaking about convolution, as many of our friends have already tried to describe it, is like that you are averaging over your signal over the time, right? And in image means that you are kind of averaging some pixels, and then you find new pixel, and then you move, and you do this process quite a lot. Now, let's see that how it happens in image processing. So there are the mathematics. We don't care about mathematics. This is what I promised to you. We won't see much mathematics. So let's see that what happens when we want to do a convolution. As I told you, convolution has no meaning in image processing except that it's like a process that you are applying into your image. But let's see that how this process is being defined. Assume I have a kernel, I have a filter or a mask of 3 by 3, and these are the weights. Who will tell you what are these weights? What's your name? Can I close your laptop? I mean, I tried to tell you a joke already, so don't worry. You can laugh back into it. So, not the scientist, application, end user, somebody will somehow tell you what are these values, right? Somebody will tell you what are these values. Assume we have a 3 by 3 mask, and the values are as it is. If you need to convolve this mask with an imaginary image, with an image, what needs to happen is that you have to do a couple of processes. So this is your input, convolution kernel, and this is also an image, right? This is a part of an image, let's say. So the first thing that you have to do, you have to rotate this kernel, 180 degrees in order to start the convolution. So step number 1, you have to rotate your kernel 180 degrees, right? So, what's your name, lady at the end? Yeah.
Kari.
Kari, do you know how to calculate 180 degree rotation of a matrix?
How to calculate it?
Yeah. It comes in exam. You have it in the paper and you have to do it. So what you do, you rotate your paper and then you have the 180 degree rotation and then you write it down. Right? So we rotate it 180 degree, which means that in the exam you just rotate it 180 degrees. If you do the computer program, you just use the command in MATLAB in rotate in order to rotate the matrix 180 degrees. So after you do the rotation, you have a kernel and you have your image. So let's say that you want to calculate what is the new value instead of this 3. You take this mask, you put it here in a way that the center is sitting on the pixel that you want to calculate. So if you do it, you will see that the number 1 sits here, the number -1 sits here. So you multiply 1 by 2, -1 by 1. So you have lots of numbers. You multiply, you add all of them, and you come to one single value. This value will be the new value that you replace instead of 3, and so on. However, we have to see what happens if we start from the corner, which means that you have to put this center on here. But before I say it, yes, you have a question.
I have a question. Why do we rotate? It's just filter.
This is a good question. This is actually something that I said I jump over it. It is because we have the definition of flipping in the definition of convolution. In convolution, in mathematics, how it's defined, you have one signal, you have another signal. You flip this one, and you go to minus infinity in time, and you start to move. This flipping is 180 degree rotation in here. But as I said, you are not responsible for this mathematics. Those of you who want to can see. If not, just believe in me. Anyway. So, we want to see what happens if I put this mask in here. Because number 2 is pixel of interest. I mean, I have not that much time, so I do that here. And number 1 is the pixel of the interest. So what I do is that I will take this mask, right? I will take this mask and I will put it in here, in a way that this number 2 will sit on here. I have no problem of these neighbors. But what will happen to these neighbors? Yeah, I will say that I assume my image is covered, the surrounding of the image is covered with lots of zeros if required. So it's like that there is a 0 here, there is a 0 here, there is a 0 here, so 0 will be multiplied by this number. So it's like that something like this will happen. I will put it in here, I have this mask, and I have this image, so I will put this center on top of this center. So you can see that these neighbors are left out. They will be multiplied by zeros. Or you just drop them. What's the difference between these? You just drop them or you multiply by 0? What's the difference?
When you drop to nothing happens, but when you multiply it turns to blank.
What's the difference? Because there are 2 approaches. One is that they drop them out. The other one is that they say that you have lots of zeros and you multiply by 0.
You might lose information.
If you drop them, then the average will be only where the filter is.
Very good. When you drop them, they don't exist. But when you multiply them by 0, they are 0. They exist. In other words, if you need to calculate an average, if you drop them, you have here 4 elements. If you multiply by 0, you have 9 elements. Right? So, which one do we have to pick? You decide based on your application. In this course, we put lots of 0. It's called 0 padding. Right? We do lots of zeros. Typically in the exam, if I need to ask something like this, I will ask from the center, so you don't need to be very confused. And if you are using programs like MATLAB, you have the alternative of deciding, but typically people are doing it with a 0 padding. Again, why we don't care much about it, do you know? Because you have a big image, 1000 by 1000, and it only affects on 1 pixel all at the edge, which you don't even distinguish it. So there is no need to put too much effort on it, right? So that's why that it's not very much of the importance. Anyway, what happened is I put the mask on top of my image, and I do the multiplication. 2 multiplied by 2 is 4. 1 multiplied by 2 is 2. Minus 1 multiplied by 2 is minus 2. 1 multiplied by 1 is 1. And I add all these numbers. They are all zeros, so I am dropping them out. So it will be 4 plus 2 minus 2 plus 1, so it's 5. Then I move to the next pixel. And I do the same process, and I get 4. And I do it for all of the values that I had. And then at the end, I will see that this is the pixel that I get. Now, you have to be careful. The output of this convolution process is a matrix. It's not an image. However, depends on your mask, the output can be also an image. So, depends on what are the values or what is the process that you are defining, the output can have some negative number or a number which is greater than 255 or float numbers, or sometimes you have to quantize the values. Here was an example which we are doing it in order to simply show you what is the convolution look like, what the convolution look like, right? Now, my friendly recommendation to all of you is, this is a slide, I will put it in module. I want you to go at home and try the rest 8, 9, 10 values by yourself. Typically, this is one of the things that you may see also in the exam. Why I want you to practice it? Because sometimes you are not very careful. You are not very careful about multiplication. I know many students who happen, due to the stress of the exam, multiply 2 by -1 and they write 4 or 2. So, and you lose point because your result will be right, simply because of a very small mistake. So practice it, it will be very good. So, what happened, we talk about something which is called convolution, and convolution does this magic of 180-degree rotation at the beginning. Yes?
In the matrix is almost each pixel multiplied 3 times then.
Every pixel is multiplied 3 times?
Yes, if you see the one is in the center,
Yeah.
that you want to change, but then when you move forwards, then the one that's in the mask, the right one multiplies it again.
No. Then you are creating a new one. You don't use this one. You still use the old image all the time. You do not update it.
Okay.
You do not update it. In neighborhood operation, then you calculate the new value and you go to the next one. You don't use the new value anymore. By default, you will use the old value and you continue. Can you define a process which you are updating a new value and you are using in the next process? Yes, you can do it. But not in any of these masks that we will talk about. So when I tell you about the convolution, what happens is that I have to tell you what is a kernel. Yes?
No, I just want to check. So when we apply the mask, we're just adding it. We're not finding the average.
No. You're just adding. You're just adding. I give you a kernel, I say that was the convolution of this kernel and your image. I just rotate, multiply, and add, and then you will get the results. Now, what happens is that we are doing the rotation of 180 degrees. There is another process in signal processing which is very similar to convolution, but it's not convolution, it's called correlation. The difference is that we do not do 180 degree rotation. You take the kernel and you do the process. And what was your name? Okay.
Range.
And just
Yeah, MIT.
Range.
Rain, yeah, sorry. You describe the correlation. When I asked what's the convolution, he described the correlation. It means that you take a piece of something and you try to see that which, and you have a huge massive thing. Inside this huge massive thing, which one has the highest similarity with what I have in my hand? It's called correlation. So the difference of correlation and convolution is that you do not have the flipping anymore. You just use the kernel as it is. The rest of the process is that you put the center of interest on the image and you do it. Very similar to convolution, but no rotation is required. So you do it, you calculate for each pixels, similar way, you go to the next neighbor, and you can calculate what is the output of the image. However, most of the time, we do something else. What we do, we are using a kernel or a filter which has fixed values inside it. Like here in this example, these values I provided to you. But now we will learn those kernels that the values inside the kernels are very different. The first thing that we will discuss for us is a filter which is used for smoothing. Filter which is used for smoothing. What is a smoothing? Yeah, we don't have the sudden jumps. We don't have the sudden jumps, right? We don't have the sudden jumps. And the first operation that we learn in order to do the smoothing is something which is called averaging filter. Averaging filter, or there is another name for it, it's called low pass filter. We will talk about it in 2 weeks' time. But currently we call it averaging filter. Averaging filter is a filter that as on its output, it will smoothen the image. Another way of saying this sentence is this. Averaging filter is a filter which will cause blurring effect. In other words, you give a sharp image, you get a blurry one, right? So you are getting older, you use your photo and you start to do averaging so you don't see the wrinkles inside the image, right? So this is an application of it. So let's see that how we want to do it. In order to do it, we have two types of kernels. The first kernel is called a box filter, which means that pure democracy, all the neighbors are equally treated. How many neighbors do I have in 3 by 3? 8 plus myself, 9 elements. So how do I find the average? I add all the values, I divide it by 9, right? It means that every neighbor has the weight of 1, including me. I add all of them and I divide it by number 9. So it means that it is a box filter. So you have to remember this, you have to memorize this. In the exam, if I tell you that apply box filter, you have to know it's this. Yeah?
I just want to clarify something. If you, for example, in the exam has to correlate something, then we just have to apply the math, and without dividing. But if you like filter.
Yeah, if I tell you that you have to convolve it, you have to rotate it. But if I tell you that you have to apply the box filter, you will do what I tell you now. But what you need to know currently, if I tell you a 3 by 3 box filter, it means that everything is 1, and you have to multiply by the weight 1 over 9, right? If it is a 5 by 5, how does it look like?
All ones and divided
by 25, right?
Yeah.
It will be like all ones divided by 1 over 25, because you are just finding an average. Another way of finding an average is that we do not treat everybody equally, and we call it weighted average filter. For a 3 by 3 filter, it has fixed numbers and it is 4, center is very important. The direct neighbors have the weight of 2, the off-direct neighbors have the weight of 1, right? So if you add all these numbers, you see that this is 16. So it's like calculating the weighted average. It's like that you are calculating your GPA. Some courses are 6 EAP, some of them are 3 EAP, so they have different weights, right? So it's the same. So if I tell you that we have an image and I want to apply a box filter of 3 by 3, this is what you do. If you want to apply the weight average, this is what you have to do. If you are applying them, and if you compare them, you see that the image, the box filter, is more blurred than the one which is with the weighted average filter. Where can I use it if I have noise? Most of the noise are being removed by this averaging filter. How do I apply it? How do I apply it? What was your name? That last question, the last point. Rhinos.
Yes.
Yeah. How we are applying it? You have now this filter, this kernel. You just put it into the pixel, into the image like correlation, and you are applying it. But what you do, you multiply the weights, you add them, and then you divide them by this number, right? And you divide them by this number. So, or in case of the weighted average, you put this one into the pixel of interest. You multiply each pixel with the weight, you add them, and then you divide by number 16. And then you are calculating the value. What is the output of this image? What is the output of this kernel? It's an image. In other words, if you calculate it, and the pixel value for 8-bit is 125.3, what do you write?
124.
125. You will write it. You cannot write the floating point. It cannot be negative. It cannot be more than 255. But it won't be because of the average of numbers is like 255. So it causes blurring effect. It is used in order to reduce the noise, and this is the way that it looks like. Look at here. We have an image. We use this image also quite a lot in our slide. The original image looks like this. Why this is a good image? Because it has lots of repetitive pattern, different intensity value, different sizes, different shape of noise, and so on. And we are start to apply a 3 by 3 box filter, 5 by 5, 9 by 9, 15 by 15, 35 by 35. Can you tell me that? What are your observations? Well, what's your name? The other lady in the class?
Marika.
Marika.
Yeah.
Marika, what are your observations? Let's see, what is the first observation you have if you compare all this?
It gets blurrier.
If you are increasing the size of the mask, it will become more blurred, right? So this is a very good observation. Observation number one, it was blurred. Simon, what's your other good observation?
You're losing the contrast between pixels.
It become more blurred. So I mean, it's not observation, it's conclusion.
Okay.
Filter size is increasing.
Hmm?
As we increase the filter size, then it's becoming more blurred.
These are all what he said.
It's not clear.
We start to lose the details in the noise part. You see, as we are increasing the size, we are removing more noise. Here, for example, in 35 by 35, practically you don't see this noise. So in other words, as we are increasing the size, we are killing more noise. Of course, we are killing more of the information of the image. The image will become worse. What is the other observation?
The edges.
Huh?
The edges, like how many pixels.
The blacks, you see, this black side, because in MATLAB, as I said, for instance, we are doing this zero padding. We are doing zero padding. In other words, if you are adding lots of zeros, it means that the average value of the edges will become dark and dark and dark. As you are increasing the size, you are having more zeros padded, so it will become thicker zeros at the edges. At the edges of the image. So this is the third observation that we have on this one. So let's see that what we can do with this blurring one. Let's say we have this satellite image. We will use a blurring mask, it's a 15 by 15, and this is what we are getting. So from this is what we are getting. Now you can convert this image that you have into a black and white. So I have a new mask, and if I use this mask and I just put it on top of this image, I can see that I'm deleting so many of these stuff. So I will be left with a very beautiful image in front of me. So this is also a very good application of blurring mask. So when I tell you that we are applying a weighted average, this is what it has to come in your mind. And when I say that you have to use a box filter, this is what comes in your head of 3 by 3, and you have to know it. I mean, you don't need to memorize it because the exam is open book, open note, but you have to know what I mean by box filter. So now, I have a question, and have your notes open and try to solve this. Can you tell me what are the weights of weighted average filter of 5 by 5? This one. For 3 by 3, you know this is this. For 5 by 5, what would it be?
8 in the middle, 16 in the middle.
16. Do it on your notes. What do we know for sure? Corners are 1. So this is a good starting point to go ahead and walk forward. This will be the highest. This one